Welcome back to ArmanisMath. Today we're going to focus on how to solve exponential and logarithmic equations. How to solve exponential and logarithmic equations. I'm going to split this lecture into two parts. The first part is going to be how to solve exponential equations, and the second part is going to be how to solve logarithmic equations. We'll start with the warm-up. I'll give you about 3 minutes, not more, for this here. And make sure that you time yourself. That's a good habit when you solve problems. That way you actually are used to testing and quizzes and stuff like that. I'm going to stop at probably the 2-minute mark, okay? But you could do this after when you watch the video. Do participate in the chat, in the comments, in the whiteboard. That's probably the best. So I was able to spot a couple issues earlier this morning and were able to fix it. So it's advantageous if you use the whiteboard. I'm going to stop it here. You guys, when you watch this afterwards, make sure that you spend the time on this warm-up as well. All right, quickly here, what do you think is going on with the first one? Can anybody tell me what's the base for the first one here? I need a lot of participation today. You need to focus and participate. Don't wait for your friend to answer. So basically I have 16 raised to what power? Here we go. 3 over 2 equals this x. And I do this by doing the loop. If you guys remember, I do the loop. So I start from the base to the exponent. That's going to give me the answer, whatever I'm looking for. And to do 3 over 2 as an exponent, if you guys remember, we said something about this half being a square root, right? Times 3 equals this x. And the half is a square root, so I have a square root of 16 to the 3rd power. Is basically what this one is saying. Equals x. What's the square root of 16? What's the square root of 16? That's the 4 to the 3rd equals x. So how much is x? 4 times 4 times 4. 4 times 4 times 4. $64 is the answer for this problem, okay? Good job. I see that, Kelly. Okay. I'm going to move on to the second one. I need to erase, obviously, here the work, but I'm going to move on to the second one. What do you think I'm doing here? I'm going to have x raised to the 3rd equals this amount here, which is going to require us to do something. So the first one is 64. This one is going to require us, again, to do that same loop. X raised to the 3rd equals that. Basically, what they're saying, you have x cubed equals this amount, 1.331. Go ahead and use your calculator for this. I'm not expecting you to know this, obviously, so off the top of your head. So go ahead and use a calculator and give me a value for this. How would you find the value for x? Use a calculator for that. So you're basically going to take the, what are you going to take here? Here we go. Cubic root, exactly. Going to take the cubic root of both. That's the cubic root of that amount. And what's the answer, you guys? Here we go, 1.1. That is true, Faith. Yep, 1.1. All right, the third one is equally amusing. What's the base if there is no base? 10. So basically you've got a 10 here raised to this x gives you that amount. So 10 to the x power gives you 1, 2, 3, 4. Okay, what could the x be? What could the x be? If this is x to the 10th equals this amount, what is that x? Yep, it is 4, Jordan. Yep. And Audrey and George. That's right. It is 4. All right. Here we go. Just a minor delay in the software. Objective today, I will be able to, that was too fast, I will be able to solve exponential and logarithmic equations. I will be able to solve exponential and logarithmic equations. One word from the objective, please, in the chat or the live stream comment or the whiteboard. I need to see whiteboards, you guys, today. It's going to benefit you, so fire up your whiteboards and let's take a look at your work. Logarithmic, solve, I. Oops. Is oops part of the objective? No, that was for something else. Okay, that's funny. Here we go. We talked about logarithms and their use. They actually used logarithm functions as in Richter scale, for example, to help us measure the intensity of the energy released by an earthquake. Also, another example would be the sound wave. The sound wave that if you're composing music, for example, or if you're into sound waves and recording, we use logarithms also for the decibels when we measure sound. So if you could find another example, share that with us on the other method that we talked about. What is an exponential equation? Exponential equation is an equation containing one or more expressions that have a variable as an exponent. To solve exponential equations, you have basically two approaches here for our level. You could write them in the same base. You could write them with the same base. And the second option is to take the logarithm of both sides. If the first option doesn't work, it's probably the easiest. Then you try the second option, which is taking the log of both sides. Okay? I'm going to talk about one thing before I talk about this example, which I'm going to doodle on the side here. I'm going to kind of baby steps here. So let's start with a baby step. Okay. First thing first, what have I said? I am giving you this item. 2 to the third equals 2 to the x. Since I have the same base on both sides of the equal sign, then also the exponents should be equivalent. If the bases are equivalent, the exponents should be also equivalent. So in this case, I'm going to say x equals 3. As simple as that. Okay. So basically, you have to set up the same base on both sides. Now, sometimes it's pretty much simple like that. Sometimes it requires you to do a little bit more. The second thing I want to say is, not this one, but the second thing I'm going to say is going to be right there. If I have, let's say I have a 4 to the x, and I have 2 to the 5th, for example, okay? If you looked closely here, the bases are not the same, right? So how can I write a base that is similar? Well, basically I have to think the 4 and the 2 have some base in common, and obviously it's the 2, right? So I'm going to rewrite the 4 as a base of 2 raised to a power. So you're going to say this 4 is actually a 2 to the second base. I'm sorry, a 2 base to the second power. But you're not going to neglect that you have an x waiting for you here. Okay? And that's going to equal to 2 to the 5th on the other side. That didn't change. Now, because I have the same bases, See that? So the exponents, the powers should also be equivalent. So I'm going to say, in this case, I'm going to say 2x equals 5. And I'm just going to solve for x. X is going to be 5 over 2. Okay, so you're going to see both of these approaches today. Some of them are going to be very simple. Some of them you just have to find a common base and then work from there. Okay. Let's deal with the problem at hand here. I've got this one states solve and check, and I really wanted you to follow both of them. I'm not going to do every single problem as solve and check, but this check part needs to be part of your solution because some of them are actually not going to work. Just have to say it right at the get-go here. Some solutions will not work, so make sure that you solve and check. I'm going to do it maybe twice in this lecture, but I'm expecting you to do it in every single example. So let's talk about this one here. I've got 9 raised to the x minus x and 27 raised to the x minus 3. Well, can somebody tell me what you think a common base I could introduce here? What's a common base you think? I'm pausing purposefully because I've seen a lot of 9s as suggestion, and here we go. Coomer is the winner in this case. 9 is way too big as a base because 9 raised to something, if the first part is 9, that's okay for here, but it's not going to be okay for here. Since you said 9 to the second, whoa, that's way too big. That's 81. So definitely 9 is going to be way too big. So I'm going to take the 3 as a common base. So I'm going to break down the 9 in terms of 3 as a base to a power. So 3 to the second power is 9. But again, I'm not going to neglect the fact that there's something here waiting for me. 8 minus x is waiting for you here. Equals. Can somebody tell me what is 27 in terms of 3 as base? 3 raised to what power gives you that amount? That is true. 3 to the third. Faith and Kelly and Marvin and George. Yes. And Alice and Ali. So 3 to the third. 3 to the third. But also, I'm not going to forget that I have people waiting for me here. X minus 3. Please be careful with your font. There is, as we talked about that last time, there's like 3 different levels. There's subscript, script, superscript. Be very careful, especially in this chapter. Now, since the bases are the same here, right? So the exponents should be equivalent. I've got 2 times 8 minus x equals 3 times x minus 3. And now I'm just going to solve a linear equation here. Very simple. So 2 times 8 is 16. That's a 16 minus 2x equals 3x minus 9. Once I do that, well, it was too big of a jump here. Once I do that, again, I'm going to add the 2x to both sides. I do not want to end up with two negatives, with too many negatives in my life, right? Focus on the positive things. Life is good. So now I got 16 on this side equals 5x's minus 9. And what do you think I'm going to do next? I'm going to add 9 to both sides. That should give me 25 equals 5x, which means if I divide it by 5 both sides, I'm going to end up with x equals 5. So x equals 5 is my answer. And highlight my answer, box in my answer here. X equals 5. So I have to check. Okay, so I'm gonna, in the first couple problems or so, I'm gonna check, or 2 problems actually I'm gonna check, but I'm expecting you obviously to to check everything, not just the first two problems. So let's check the work for this dude here. I'm going to go all the way to the top and see if I could go to the problem itself. Okay, I'm going to go to the problem and check my work in the problem itself. Okay, so let's go here and try to check my work down here. I'm going to say this step is the check step. Does it work or not? Well, I have to check. So this one says I have does 9 8 minus x to the 8 minus x equals 27 x minus 3. My x was 5, so 9 of 8 minus 5, does that equal to, I'm asking a question, we're testing, we're checking, we're not sure. Does that equal to 27 to the 5 minus 2, 5 minus 2? This is 9 to third. Does that equal to 27 to the second? Is that true? Can somebody punch in the numbers? Somebody punch in the numbers for us. What is 9 to the third? $729. Okay, and what is 27 to the second power? 27 to the second power, 729. Looks good here. Looks very good. So basically, you just confirm that your answer does work, and that's how you check it. So part of your taking notes, when you submit the notes, make sure that you check the answer. I'm not going to show every single example, as I said, but make sure that you check the answer. I know it takes time, but you're also going to be seeing something that doesn't work. So that's why we check the answer. Okay, here we go. Here's another one. Here's a check part. Here's another one. This one is a little bit similar. Okay, it's simpler, I should say. This one is, we're still under the solving exponential equations, and then this one says solve and check. So let's solve. What do you think the base I'm going to pick here? What do you think is the base I'm picking here? 3. That's right. Between the 27 and the 3 is 3. 3 to the 2x equals 3 to the third. And then because you have similar bases, why don't you finish this one for me? Finish it up. You guys could do this easy. What could be x at the end? What could the x be here, since I have a happy face for this? Okay, it's like a lot of you are typing, multiple users are typing. Okay. So I said 3 to this 2x, so basically I'm going to say 2x equals 3. Well, what is x? Well, divide by 2. That's going to get you the x. X equals 3 over 2. So how do you check that? Well, plug it in. If I'm mentally here, if I plugged in 3 over 2, so 2 times 3 over 2, that's 6 over 2. That's 3 to the 6 over 2 is going to give you 3. 3 to the third is going to be exactly like 3 to the third. So that should work, okay? But please make sure that you show me work as well, not just mental math. It's okay, Cole, I know. Sometimes it happens with me as well. I realize there's some delay in the chat. Okay, whoa, that was too fast. Okay, here's another one here. This one says solve and check. We're still under the exponential equation. Now the question becomes, can I have a base here that is similar between the 4 and 5? I don't think so. So in this case, what we need to do is use the second approach, which is introducing the log. You basically have to introduce a log to both sides. So in this case, I have to introduce a log on the left and a log on the right. So I'm going to say log base 4, and make sure that you're again careful with the exponent, equals log base 5. Remember, this is a common log. What's the base if there's no base for the log here? 10. That's right. So I'm introducing a common log here, and if you guys remember the properties of log, right? So I have to kick this one out. Remember that? So you're going to say this is x, let me give myself more room here, x minus 1 times the log of 4 equals the log of 5. Okay, since this is a 2 unit, this you're multiplying here. For example, you're saying 2x equals 5. Well, how do you solve for x? You divide by 2, right? You divide by 2. So x equals 5 over 2, right? We know that. Yeah, can you do this one if x is added to the 5? If this is like 2, I should say. If I have 2 plus x equals 5, can I divide by 2? Can I divide by 2 here? Hello? Can I divide by 2 here? Is that possible? Nope, this is not true. You can't, because the 2 is connected to the x. So you can't do this. Since I am multiplying here, I'm able to divide. So basically, because you're solving for x, you want to isolate the x on one side, and what's bothering us is this guy here. So I'm going to basically divide both sides by log of 4. Okay? If I divide both sides by log of 4, I'm going to get rid of this one here. It's going to give me 1. So basically I got x minus 1 on this side equals log of 5 divided by log of 4. I'm not expecting you to know log of 5. That's why you have to use a calculator for. And before I punch in the number calculator, I just have to add this one here to both sides. So add this one here to both sides, which is going to give you a value. So basically I have x equals log 5, which you have to punch that in the calculator, a log of 4, which you have to also punch that in the calculator, plus the 1. So somebody help us with log 5. Go ahead and plug in log 5 in your calculator and give me the give us the value that you get. Come on, champions. Give me like 3 significant digits would suffice. 3 significant digits. Don't wait for your friend to try it. You try it as well. You could also try. Remember, you could try it on Desmos. So you have access to Desmos right next to you on your app. Okay, divided by log of 4. Can somebody tell me what's log of 4? Can you give me one more another significant digit, like 3 significant? Here we go, 602. Go ahead and divide this. If you have a calculator that could do this in 1 step, you're good. If not, then you just have to do it in 2 steps. What do you think is going to be the answer for you guys here when you divide these up? I am looking at x equals approximately, so I'm approximating here, that's the tilde. Look into log 5 again. Why some of you are giving me, what's the value for log 5? Log 5? 699. And log of 4. Log of 4. 0.602. And if you divide these up, what would you get? 0.699 Good. That's very good. So I end up with basically 1.61. I'm sorry, 1.161. That's right. But I still have the 1 still waiting for me here. See, this is plus 1. Don't forget the plus 1. 1.16 plus the 1 that we just added to both sides, which is going to give you again x is finally x is going to be approximately this tilde means approximate, it's not equal to 2.161. Okay, that's the value of your x. So how do you check this kind of problems, Armani? Well, you have to put this, for example, in my case, I would go and put in the calculator, I'll put 4 raised to, this is the raised to in the calculator, raised to the 2.161, and see is that go ahead and try this one out. See what you're going to come up with here. What would the value here be when you put that in a calculator? So basically, I'm using a calculator to check my answer by plugging in. I'm sorry. Hold on one second. I made a slight mistake, which is 2. The equation itself says. Look at the equation at the top. It says 4 of x minus 1. I've got to check minus 1. I did not subtract 1. So when you do the calculator, go ahead and subtract the 1 here. So this is 6.1 minus the 1. Basically, you're saying it's 1.16. And yep, that equals to the 5, or approximately 5. It's not exactly 5, by the way. It will give you like 5.1 and 2 and 3 significant digits, which is pretty good approximation. So you're almost 5. Okay, so just keep that in mind as you check your answer in the calculator. It will give you pretty much approximation, not exact. It's not going to be just 5. Okay, that's how you check your answer. All right. Any question on this one before I move on? Any question on this problem before I move on? Okay. Any question on anything that we covered thus far? How are we doing here? Give me a thumbs up if you're doing good. Give me okay, groovy, you're fine, moving on, chugging along, something like that. Something. Okay. We're going to do more. Pretty good. That's good. Okay, it's okay. We're going to take a look again, Gavin, okay? So there's more coming here. So let's think about this dude here. This one says solve exponential equation. Basically, now again, I'm going back to the concept of either writing this in a common base. Is it possible to write this in a common base? I've got 7, I've got 21. Marvin, you're right. If there's no common base, you log. I love that. Or if there's no common base that I could write it in. So 7 is too big, you're right. 7 is way too big, because if I put 7 here, 7 to the first is 7, 7 to the second is 49. Well, that's way too big. So basically, I can't really match a base here. So in this case, I've got to have to introduce a log. So I'm going to introduce a log of both sides. 7 to the negative x equals log of 21. Okay? So I am going to kick the negative x out. Log both 7 of 7 equals log of 21. Do you think I could divide by something here, or we're good? I'm going to divide by log 7 on both sides. In this case, I have to, okay. And I do have a negative x waiting for me outside here. Negative x is just really eager to find its value here. What's my value? What's my value? Okay, hold on. Hold on there. Now negative x equals this spiel here. The log of 21 over log of 7. Okay, obviously I'm not expecting you to memorize stuff like that, so you're going to have to refer back to your calculator. Okay, somebody help us with the values here. Log 21 and log of 7. I see 1.33, Kelly. See that? Log of 7. Any ready for log of 7? 0.874. And if we could divide both of them, can somebody guys give us a value here? 1.322. And this one is 0.845. It looks like we're headed towards a value that looks like 1.565. Now I wanted you to be aware that this was the negative x, not the x. So if you want the x, obviously you multiply both sides by -1 or divide both sides by -1. So x equals the negative of 1.565. All right, so that's going to be the negative value of this. All right. This one is also another exponential equation, and this one says solve and check 2 to the 3x equals 15. Can you try this on your own? Try this on your own and let's see what you can get. I'll give you a few seconds for this. First of all, can we have a common base? Okay. What's my first step here? That's it. I'm going to take the log of both sides. I'll take a log of both sides. So that's going to be a log of 2 to the 3x power equals log of 15. 3x is kicked out times the log of 2 log 15. Divide both by the log of 2 log of 2. And this means I got 3x equals this value here, log of 15 over log of 2. Somebody punch in the numbers and let us know what you guys got. Kelly says log of 15 is 1.176. Good job there. Anybody for log of 2? Log of 2 from Elijah has a 0. Confirm please if you 0301. Confirm both cases, you guys. Are we good? Both are good? Si, okay. Si, senor. Si, maestro. All right, here we go. I've got 3. Can anybody give me the value for this dude here? 1.176 over 0.301. 36 equals 3.907. That's 3 x's. So I need to multiply both sides by 1/3 to get rid of that amount. next to the x. X is going to be 1.302, and it's approximate again. You're approximating. And that's going to be the answer for this problem. Approximately that amount. Okay? Any question on this? Any questions on this? So are we going to be able to use... Yes, yes. You have the access to Desmos, and Desmos actually is part of your software, so you definitely could use it. I wouldn't use it for simple ones, obviously, but for things like that, definitely use it. Okay. All right. I'm going to start the second section here. Welcome back to ArmanisMath. We're going to focus on how to solve logarithmic equations. Logarithmic equations. First of all, what is a logarithmic equation? It is an equation with a logarithmic expression that contains a variable. So basically looking for x's or y's. You can solve logarithmic equations by using the properties of logarithm, which we need to review a little bit of before we get started, okay? This one says if log base b of x equals log base b of y, then x equals y. If you have the same log of the same base on both sides of equal sign, then what's in the log is equivalent as well. So let's review some properties of logarithm. Did you guys like the video about logarithm that I posted? Did you see the many logs in the thumb? Why didn't you guys give me some emojis or stuff? I asked you to reply with emojis. Only a couple of you replied. Come on here. Try to make it fun for you guys. Anyways, that's beside the point. You guys are awesome. Let's review some properties of logarithm. So first of all, if you guys remember, we had the property that we talked about earlier today, which was the power property. You guys remember that? Log base, let's say 100 of 3. What's the base here? What's the base here if there's no base, you guys? 10. So basically I have a 10 hidden here, and then I have 3. So you basically put equals. You're gonna say this is 3 log base 100. Okay, what is 100? How do you go from 10 to 100? 2. So basically the value here is 2, which means in this case is 3 times 2, which is 6. We talked about this property. We did some of it today. Now, what about the other ones? Do you guys recall something that starts like this and then move on to something? What would that property be? From addition. Yeah, from addition to what though? This property takes you from addition to what? Here we go, multiplication. Yep. And vice versa, obviously, right? So let's take an example here. Let's say I have a log of 5 plus log of 2. Well, this is log. This is log of 5 times 2, which is going to be log of 10. So the question is 10 raised to what power gives you 10? 10 raised to what power gives you 10? 1. And 1 is the answer. Okay? What was the other one, by the way? Does anybody recall? I went from addition to multiplication. What's the other one? Here we go. Subtraction to division. Subtraction is going to take you to division and vice versa, right? So I'm going to say log. An example here would be, for example, I'm going to say 100 minus log. I'm going to say introduce a base of 5 here. Let's say log of 4. Well, the property says it's going to have 100 divided by 4, same for the same base, which is log of 5. What is 100 divided by 4? 25. So now my question is 5 raised to what power gives you 25? Remember, when you solve logs, your brain is thinking exponential because it's easier for us to see. Jenny, I see that page. And Kelly, yep, it's 2. Okay, so keep these properties in mind. Another property that we talked about, which we do not use that often, but it's the undo property. So for example, if I said 7 raised to log base 7 of x, well, remember, I'm going to actually, let me write this as really big, so just to show my point here. 7 is the base raised to log of the same base, 7, of x. Well, does anybody remember something here we did talk about last time? This does something here. What did we call that thing? Come on, champions. Armani calls his students champions. Undo. This is gonna go bye-bye. Woo! And leaving you only with x. Okay, keep these in mind as we discuss the next section here. Here's the first one. We are solving a logarithmic equation. It says solve log base 6 of 2x minus 1 equals -1. Okay, and my thought is I want to get rid of this log, obviously, that aches me here. I want to solve that thing. So I could introduce a base to both sides. I'm going to introduce a base, obviously, to cancel this 6 here. So I'm going to introduce a base that has a 6 in it. So my base will be 6 raised to this spiel here, log base 6 of, be careful with your writing, don't mix stuff up, or 6 raised to the -1. I introduced a base to both sides. The reason is I want to do the undo thing. This thing is going to disappear, right? That's going to go bye-bye, and that's going to leave you with 2x minus 1 equals, well, 6 to the -1 is 1 over 6. I'm going to add 1 to both sides, so 2x equals 1/6 plus the 6 over 6. 1 is 6 over 6, right? And the 2x is going to give you 7 over 6. Then you multiply both sides by a half to get rid of this 2, which will give you x equals 7 over 12. And I cannot simplify that further, so I'm going to just leave it the way it is, 7 over 12. All right, champions? Champions. If you need time to write, obviously make sure that you watch the video afterwards. That's why you have the link. Here's another one here. This one says solve logarithmic equations. I have a base of 5. And I have x to the 4th equals 8. So in this case, I'm going to actually use the p log, the power log. I'm going to kick this dude outside. Kick the 4 out. So if I moved the 4 outside the log, that becomes 4 times the log of 5 of log base 5 of x equals 8. Well, this is something times the log, so I'm able to divide both sides by that 4 because it's something times the log. So divide both sides by that 4, which will give you a log base 5 of x equals 2. Now comes my exponential brain, my side of the brain. 5 raised to the second power gives me x. What do you think x is? What could x be? Five to the second is x. X is 25. And definitely check your answers. If I put 25 here, for example, so if I put 25, let's deal with it here, it's easier. So 5 raised to what power gives you 25? It's 2. 2 times 4 is 8. So this one is correct. Here's this one here. This one says solve logarithmic equation. This one has log base 4 of 100 minus log base 4 of x plus 1 equals 1. When you see this negative here, what does that trigger in your brain? What kind of, does this ring any bell here? That negative? Hello? Anybody home? Hello? Division. I'm going to move on from subtraction to division. Okay. Subtraction to division. Subtraction goes to division. And you could go backwards as well. Okay. So I have, basically I have log base 4 of 100 minus x plus, with minus becomes a subtraction of x plus 1 equals the 1. Okay. Now to get rid of this log base 4, I'm going to introduce a 4 as a base. Okay. So I'm going to say 4 raised to the log base 4 of this spiel here, this thing here, of 100 over x plus 1. That's going to give me a 4, again, as base to the first power. All right. This thing is going to disappear. Do you remember? This thing is going to go bye-bye, which is going to leave you with 100 divided by x plus 1 equals 4, because 4 to the first power is 4. And then you cross multiply, because this 4, you could make this 4 over 1, right? Make this guy 4 over 1. And cross multiply. That becomes a linear equation, so 4 times x plus 1 equals 100. Okay? Now I'm going to divide by 4 both sides. I thought I picked a different color here. That's going to give me a x, and x plus 1 equals 25. And then I just have to subtract 1 from both sides. That's x going to give me 24. Okay, wait, so you can just make 4 the base if there is 4. Yes, indeed, Kumar. We do that so we can get rid of the log. So we're basically going to have just an equation without the log. Yep, that is true. I do have a few more examples, so you do have the link to the video if you feel that you need to slower pace for this case. Okay, this one goes like this. This one says that you have log base 12 of x plus log base 12 of x plus 1 equals 1. What? So what's that property that goes from addition to what? Addition to who? Addition to Yep, addition to multiplication. That's what we're going to do. From addition to multiplication. That is our weapon at this moment. From addition goes to multiplication. Or you could also reverse that. So I have log base 12. Can somebody tell me what I'm going to multiply here? Multiply what by what here? Come on, you guys. Most of you had breakfast. Yellow. Multiply what by what? If I moved from addition to multiplication. Yes, indeed. I might have to multiply the x times the x plus 1, which is going to give you equal to 1 here. Okay, and again, I'm going to do the same trick. I just have to introduce a base. So I'm not going to rewrite this whole thing again. I'm just going to introduce the base here. So this 12 is my base raised to this power. Well, hold on a second. Let me just take that further step. I'm okay with that. So 12 raised to the log base 12 of x times x minus or x plus 1 equals 12 as a base to this number here. And if again you recall, if you have a base raised to a log of the same base, this thing is going to go bye-bye, leaving you with x times x plus 1 equals 12. So we're going to gonna be patient here because it looks like we're going to have a quadratic equation coming up here. Okay, so x times x is going to be x squared. So I'll end up with x squared plus x equals 12. Well, remember, you still want to solve for x, so it looks like we're solving quadratics here. Subtract 12 from both sides. And I am looking at x squared plus x minus 12 equals 0. What? Yes, you have a quadratic equation to solve. What can we do? All right. Okay, and in this case, I'm going to start with x squared plus x minus 12 equals 0. What's ABC here, you guys? What is ABC? Looks like Kelly and George are here. So I see an A equals 1, B equals 1, C equals negative 12. Okay? And basically, I'm going to use a diamond to do that. Negative 12 at the top and 1 at the bottom. What do you think numbers are here, number-wise? What do you think two numbers multiply give you negative 12? Same numbers add give you 1. What could these two numbers be? Be the change you want to see. Well, hello. 1 and 12, that's way too big. Let's try this. Let's try 4 and negative 3. 4 times negative 3, that works at the top, thank you. And 4 minus 3 is, yep, that works at the bottom as well. Since A is 1, I don't have to divide by the A, so I just have to circle my potential factors here. So I am down to x plus 4 and x minus 3. These are my factors. So let me take them in this side now. So I have x plus 4 and x minus 3 equals 0. And by the zero product property, we know that you could set each one of them equal to 0 and solve. X equals, I'll give myself a little bit more room here. I know this will have been a long problem, but it's okay. -4. Or, obviously, x is going to equal to x minus 3 equals 0. X is going to be equal to 3. So two different solutions here. Two different solutions. Now, I'm not sure which one would work, which one would not. I just have to check. And for this one, actually, I'm going to check with you, okay? So I've got potential, and that's why I have kind of a blue circle around the answer. I did not box in the answer yet. You don't have a green or box in the answer yet. So why didn't you do that, Armani? Well, let's check it out. We're going to check the work. What? It's been almost a page here. I know. But you have to check the work. Let's see if I could plug in -4. So what is the example? What is the problem? It states log base 12 of x plus log base 12 of x plus 1. And we're asking if this equals to 1. Remember, we're checking. We're not sure yet. So let's check the -4. Actually, let's check the 3 first. I'm going to check the 3. So check the 3. So that's going to be log base what? If I check the 3, it's going to be log 12 of 3. Which I'm going to say times 3 plus 1 is 4. Does that equal to 1? Well, log base 12 of 12. Does that equal to 1? Oh yeah, big time, yeah. Yes, it does. So 3 would work. Now let's try the -4. And it's not going to take us too long to find out what's going on here. Log of 12 of -4. What just happened? Well, what just happened is you can't have a log of a negative number. You have a log base 12 of -4. Well, that's a problem. There is no log of a negative number. And if you guys recall what we did with the initial graph of the log, when we graphed the log, which was the inverse of the exponential, the log, if you guys remember, it was like this. That's the log, right? And there's no log of a negative number. There's an asymptote here that you cannot cross. There's a vertical asymptote down here. So this green thing would not get here for the parent. There's no log of a negative number, basically, it's what they're saying. So you have to reject -4. So x cannot equal to -4. Yes, it was a solution, but it doesn't work. The only solution here is just a 3. Okay? Yes? Yo-yo? Only a 3 would work here. All right, champions. So for the sake of time, I'm gonna close it here. There's obviously a couple more examples that you need to take when you watch the video. And this is the quiz that you do towards the end, right? I'm going to give you a few seconds here. So before I put the answers for the quiz, couple comments on the work that I've been receiving lately. I've seen a lot of awesome work, exemplary work from a lot of you. A few are giving me the answers to the quiz the way you see them here. and that defeats the purpose. I don't want the answers. I'm giving you the answers. You gotta show me the work that solidifies the answers. So make sure that you show me the work, okay? Don't just give me the answers. But I'm seeing a lot of good work from you guys lately. Okay, if you get bored while studying, or you need some relaxing music, I did upload a relaxing and focusing music, study music video. Take a listen to that in your free time. Okay, that should conclude our lesson today, and I will see you next time. Be blessed wherever you're at.